This video poster presents a book about Australasian tektites. It contains 42 chapters, as well as a dictionary and a reference list. After watching each video poster, you can download relevant chapters for detailed readings, using the link in the description below. This poster is about splash-form nuclei and nucleation points. Nucleus splash-form tektite number 16, is from Dalat in Vietnam, and shows many burst bubbles on the top and button surfaces. On the top surface a nice tiger claw radiates out from the percussion impact point. 3 processes have been proposed for creation of bubbles: mechanical entrapment, physically dissolved gases, and by thermal volumetric changes, each resulting in slightly different bubble sizes versus rank. In splash-form tektites this leaves very few bubbles in the glass matrix but plenty of burst surface bubbles. This is illustrated by a polished splash-form tektite without bubbles in the matrix, and the surfaces of tektite splash-form nucleus number 539 and shell number 73, showing both the concave inside and convex outside. The outside contains many more burst bubbles than the inside. Some bubbles can coalesce creating larger bubbles. Size ranking: the bubbles on the convex side of shell number 73, shows a steep gradient of small bubbles, and a very steep gradient for coalesced large bubbles. This could be creation type 1 from expelled mechanically entrapped gases. Size ranking: the bubbles on splash-form nucleus number 16, show a less steep gradient for small bubbles, but the same steep gradient for coalesced bubbles as shell number 73. This could be creation type 2, from physically dissolved gases after pressure release. Large bubbles may not burst, but collapse instead, leaving a dome surrounded by a rim of stretched glass. Nucleation sites are impurities, like suspended particles or minute bubbles in a liquid, resulting in heterogeneous nucleation. In splash-form tektites many surface bubbles on shells contain partly melted quartz grains, embedded in their inner surfaces. Such grains may have acted as nucleation sites, enabling the bubbles to grow large, quickly enough to ascend to the shell surface. Probably type 1 bubbles from mechanical entrapped gases. The sizes of the embedded grains are around 1/10 to 1/100th of a millimeter. Read more about splash-form tektite bubble creation in Chapter 03, dependent on viscosity, temperature, and surface tension. Download Chapter 3 and 4 from the link below, to read more about these topics.